Thank you very much. And I'm Alessio Paonessa. I'm presenting the case of study of Riva Ligure, where oh, sorry, where we tried to develop a method to record with photogrammetry the stratigraphy we were digging. So, the main goal of this presentation is try to describe the method. We started with a traditional drawing method on paper and widely used in Italy. And then we switched to a method only with photogrammetry. To try to explain then what we want to do in the future, because just for now we are using only 2D documentation to record this, and we would like to move to only a full 3D modeling for all the stratigraphy. So actually, I had also a lot of interesting tips from your presentations, because it's only the beginning for me to develop this method. So it will be really interesting also to listen to the other presentations to have more tips. A little history of the research. The site was first discovered in the 19th century because they excavated and built the southern road on the coast, and they found the site on this side. The first real excavation, archaeological excavation, was made by Nino Lamboglia in 1937, and they started with the baptistery. It digged only the baptistery mainly, not more. In the 18th century, then in the 18th years, then they excavated also the whole area, but not with a stratigraphical method, actually. And this gave us problem in the interpretation of the data. Since 2009, the excavation is led by the PIAC, the Pontifical Institute of Christian Archaeology, and Nino Lamboglia's Foundation. We use only an open area method, and we are still digging it. The excavation, the research is always on the way. So, I'm sorry, I think it's not so visible. I will explain the church. The church is the only example of a church with an internal narthex in all Liguria. The data about Christian Liguria are really fragmentary at the moment. The internal narthex is here, and we have 3 naves. These 3 naves were used for funeral function, maybe at the very beginning of the church, which was constructed in the 6th century. Then it was in use as a rural chapel, which is here, just to the 5th century. And it was only a rural chapel since the 10th century, when the settlement moved from this area to Taggia in the valley. So, at the beginning we used squares and multilateration. So we made many pegs on the field, and we used the multilateration with 3 or 4 pegs to try to find the position of every stratigraphical unit. For the altitude, we use a level. We had only 1 point on the sea level, and then we made all the calculation to find the altitude for every stratigraphical unit. And we also had many sketches on notebooks. This was just to 2011. Not an efficient method, of course, because the technique is really slow on the field, It takes a lot of time to the excavation, and we don't want this, of course. The record was on paper, so we had to scan every plan and every section, and to vectorize them after the field work. Really expensive in terms of times. And every metal stack was really difficult to maintain. They were overall the area, and when we dig it down, then of course they moved and they were not trustable anymore. So we tried to use photogrammetry, and this was a really good idea for us, because with photo catching we could record many stratigraphical units in the same time. It was really simple. For it requires only a photo camera, nothing else. The ground control points are easily to manage instead of stacks, and they are they positioned on the walls actually, so we didn't touch them excavating. And the rasters produced by this method were already georeferenced, so we didn't need to digitalize anymore the plans, for example. The first process was based on Edges of Photoscan, really good software. Many people here are already use it and presented it. Actually, we had budgetary constraints, so we use a telescopic pole, gardening telescopic pole, with an Nikon Coolpix attached on it. It was a really economic solution, but not optimal. And then we vectorize the stratigraphical units in QGIS or AutoCAD directly on the raster. On the raster of the orthophoto and the digital elevation model. So what we wanted to improve, actually Edges of Photoscan is proprietary software. So we don't know exactly what they're doing during the elaboration. The results are accurate, of course, but we would like to have more flexibility on the process. For example, batching the elaboration with common languages. We would like also to build an open multi-platform protocol, so to use it in Linux, macOS, and Windows. And we would like to also improve speed and flexibility of the process, because we would like to have results also in other formats. So we tried the software called Micmac. The software is developed by the IGN, Institut Géographique National in France, and it's released under a GPL compatible license. This software is used usually for UAV or close-range photography, and makes all from the type points to the 3D model and orthophotos also. We switched to a carbon telescopic pole because the gardening telescopic pole was flexible, and so we didn't know exactly how much height was on the stratigraphical unit. We used also APS-C Canon EOS 600D, better resolution, of course, because the final resolution of the photos was actually improved. And in QGIS, we used the terrain profile and point sampling tool to try to make a stratigraphical unit, the altitude on stratigraphical units, and every section on the field directly with orthophotos. We tried also to use QGIS through 3G JS, but we have problems now. I don't know exactly why. It's interpreting not a good way our orthophotos. We just don't know why. So the pipeline, as I say, the Micmac can do all the process from internal orientation, to external orientation without or with the georeferencing. And we can mask, of course, photos and models. We can make sparse and dense cloud, orthophoto mosaics, and also 3D models. They are not so good at the end because we don't use the exact method to take photos with the telescopic pole. So we use also MeshLab for texture and 3D model. So we made also a comparison with Pix4D. Pix4D is a commercial proprietary software, really good actually. And we have seen that Micmac requires more overlapping than Pix4D for a 3D model or an orthophoto. It requires also higher precision on ground control points because we tried also with few ground control points to make orthophotos, but Micmac many times failed on this. And but when the set of photos and ground control points were good for Micmac, the results were comparable with Pix4D. Not for 3D. So when we take bird's eye photos and we try to build a 3D model, Pix4D it's way longer better than Micmac. So in QGIS we try to visualize the 3D documentation with planar sections. We overlap them over orthophotos to build the sequence. And we use the terrain profile to show sections. So this is, it's not so visible, but this is, for example, a section built with the terrain profile plugins. This is actually the blue line, it's the first level at the beginning of the excavation, and the red line is the final level. This is the last product, the plane we are giving to the Cultural Heritage Office in Liguria, and as you can see, the altitude is highlighted with some points simply. So we tried also to make a comparison on the sector M. This is the case study. This is the one of the last sectors opened at the north of the church. We had only 2 photo sketching at the beginning and at the end of the campaign, and with 16 ground control points and 138 photos, we achieved a resolution of 2 mm per pixel. This is a comparison, and in the last one we can see that actually the results are really similar, are the same. This is also the result of the vectorizing of every of a stratigraphical unit. So we tried also to build a 3D model on the field, and we take it with 90 pictures with the method required for Micmac. So one at the center, up, bottom, left, right. And we tried also to achieve the maximum quality process possible. And the final model was with the 70 billion of vertex and 7 billion of triangles at the end. And this is the last result. I'm sorry, it's not so visible. We also give the documentation to the Liguirian Cultural Heritage Office. We make a list of every plan and section in ODS format and PDF. For every stratigraphical unit plan, we gave a shape and a PADF, and all the information will be uploaded to CGIC, the WebGIS system in Italy. We also build a wiki with all the information about the process we used. It's the only Italian wiki with this kind of information about open source application of photogrammetry. as far as I know. We want to publish it after a migration to DokuWiki, because now it's in Zim and it's a local wiki. And we also would like to expand and diffuse our open protocol to produce this kind of documentation. What we want to improve, it's we want to start the vectorization process over the orthophotos directly on the field, so with tablets and software like QGIS directly on the field, and not do after the excavation. We would like to make 3D sections starting from the 3D models of every stratigraphical unit, and also implement the standing metrics, which gives us the possibility to collect all the information directly on the graphical interface. And actually, the open protocol is still in development. It's not the end. We use a mix of 2D and 3D technology. Thank you for your attention.